Okay, so this is the type of the problem that we had yesterday. The main type, finding all 6 trig ratios. But the first thing I gotta do is find this missing side. So how do I find that?
45, 45, 90.
It is? How'd you know that?
The 10 is x would be x or square root of 5 times square root of 2.
Good. Yeah, if you were thinking about, the square root of 5 times the square root of 2 is the square root of 10, remember on a 45, 45, 90, that's how it always is. This hypotenuse is always radical 2 times that. So if this is a 45, that means this is radical 5. So that is correct, sir. Now you could have done Pythagorean theorem and you still would get the same thing. Okay? All right, so if you did Pythagorean, you would have gone to square root of 5 squared plus b squared equals square root of 10 squared. All right, a squared plus b squared equals c squared, right? And the square root of 5 squared is 5. And the square root of 10 squared is 10. And then when you subtract the 5, you get b squared equals 5. So to get b, you have to take the square root of 5, right? So that's, but if you recognize it like Tommy did, you learn that 45, 45, 90, 30, 60, 90, you didn't have to do the Pythagorean. Okay, so the 6 trig ratios are, see if I can squeeze them in here, sine, cosine, tangent. Those are the 3 main ones. And here's theta, so opposite the square root of 5 over hypotenuse, square root of 10. Well, since both of these are of the radical sign, I can divide 5 into 10, make that the square root of 1 over the square root of 2. Well, I know the square root of 1 is 1. The square root of 2 I got to leave, but I have to rationalize it. So it's the square root of 2, 1 times the square root of 2, and radical 2, or square root of 2 times square root of 2 is the square root of 4, which is 2. So it looks like that. Okay? What's going to happen with cosine? Adjacent over hypotenuse. Going to be the same thing, isn't it? When it's a 45, 45, 90. Tangent is opposite square root of 5 over adjacent square root of 5. Well, anything divided by itself is 1, right? And then the other 3 would be cosecant, reciprocal. So square root of 10 over square root of 5. Which 10 divided by 5 is 2, right? Square root of 2 over 1. And that's what's going to be the same here. Secant. I should put theta, right? Forgot that part. All right, would be the same answer. Square root of 2, square root of 10 over square root of 5, so square root of 2. And then cotangent is the reciprocal of tangent. And the split that is still square root of 5 over square root of 5, so it'd be 1 also. So you could save yourself some work if you realize, like Tommy did, that radical 5 times radical 2 is radical 10. It was a 45, 45. But it wouldn't take you much extra work to use Pythagorean to find that missing side. So that's the type of stuff we were doing for numbers 3, 6, 9, and 12. A few of you just had like one answer. Like you just found the missing side, but you didn't write all the fractions. So make sure you do the whole thing when we get to the quiz on Friday. All right, so number 3, the answers are 94, right? All right, so number 3, the sine was 4/7, so the cosecant was 7/4. The cosine was a square root of 33 over 7, so the secant ends up being 7 times the square root of 33 over 33. And the tangent is 4 times the square root of 33 over 33. So the cotangent would be the square root of 33 over 4. So the missing side is the square root of 33. Square root of 4, 49 minus 16 gets you 33 when you do Pythagorean. Number 6, sine is 5/8, so the cosecant is 8/5. The missing side is the square root of 39, so the cosine is the square root of 39 over 8. The secant is 8 times the square root of 39 over 39. And then tangent is 5 times the square root of 39 over 39. And cotangent is the square root of 39 over 5. Any questions on 3 or 6? Again, you just had to find the missing side using Pythagorean theorem. Number 9, same type of problem. Square root of 3 over 2 is the sine. So the cosecant would be 2 times the square root of 3 over 3. The cosine is 1/2, so the secant would be 2. The tangent is the square root of 3, so the cotangent would be the square root of 3 over 3. Number 12 is a 45-45, just like the warm-up. So same answers as we got number the warm-up. So sine is radical 2 over 2, cosecant is radical 2, cosine is radical 2 over 2, secant is radical 2, tangent and cotangent are 1. Number 15 was 4/5. So I'd like to look at that one with you just for a sec. So it's got a picture of a right triangle. And, well, you had to make a picture, I guess. So I always make it look like this. Okay, and it tells you for 15 that the that the sine was 3/5. So that was in the directions. Sine of theta is 3/5. So here's theta. So remember, 3 is the opposite side, and 5 is the hypotenuse. Okay? So you had to find this missing side. Okay? Well, since I've done so many of these, if that's a 5 and one of these is 3, the other one's got to be a 4. It's that basic 3, 4, 5 right triangle. But if you do your Pythagorean, a squared plus b squared equals c squared, you get 9 and 25. When you subtract 9 from 25, you get 16. Square root, you get the 4. Okay? So for 15, from the information you're given, you draw the picture and then just answer the question. You only had to find one thing, and it was the cosine of theta. But you had to add, you didn't have to find all of them like we did for the first 4 there. So cosine of theta is adjacent 4 over hypotenuse 5. So that's all you had to do on that type of problem. 18's like that. They tell you the tangent's 4 over 3. You have to find the secant. Again, it's a 3, 4, 5. So, our picture, if the tangent of theta is 4 over 3, theta would have been moved up to here. Opposite 4 over adjacent 3. The hypotenuse is 5. Still, it's a 3, 4, 5. And secant is the reciprocal of cosine. So cosine of this is 3 over 5. So secant would be the reciprocal. So the answer to number 18 would have been 5 over 3. Okay. And then for 21, they give you, the secant of an angle, we use beta this time instead of theta, is 13/12. So the missing side is a 5. And then when you do the problem, the cosecant is gonna be 13/5. 24 is, like that as well. They give you the cosine is 2/3. All right, so, however you make your right triangle, cosine is 2/3, adjacent over hypotenuse. So you have to find, not this 3 squared is 9 minus 2 squared. Oops. 3 squared is 9 minus 2 squared, 4 equals 5. So this would be the square root of 5. And then the problem you're supposed to answer is tangent of theta. So opposite square root of 5 over adjacent 2. Is this making sense to you guys? So they're giving you in the directions one of the tricks. You just draw your picture that fits it. Find the missing side using Pythagorean, and then answer the question. Okay? You have stuff similar to that on your practice quiz and quiz. All right, number 27 was next. Okay, I'd like to go over these two to make sure you guys understand them. Again, they want the exact values, so you can't just put in your calculator. The calculator gives you approximation because it gives you decimals and rounds it. Right, so this is the sine of 30 times the cosine of 60 minus tangent of 45. So what we do is we just think about our 30, 60, 90 triangle and our 45, 45. Okay, so my picture for 30, 60, 90, I kind of squeeze it in here. So I'll make that the 30 and this the 60. All right, remember 30 is the short one. I always make it 1. The hypotenuse is always twice as long as the short leg, so I make it 2. And the long leg opposite the 60 is always the short leg times the square root of 3. So 1 times the square root of 3 is the square root of 3. For the 45, 45, I made them x's, but I like to do 1, 1, and then the square root of 2. You don't have to worry about canceling x's and stuff. So sine of 30 is opposite over hypotenuse, so that's 1/2. Times cosine of 60 is adjacent 1 over hypotenuse, 2, which should be 1/4. When I multiply those, 1 times 1 and 2 times 2, right, Jordan? Minus tangent of 45 is opposite over adjacent 1/1. So what's 1/4 minus 1? -3/4. That's the answer to 27. That's the exact answer. Now it might work out, since that would be 0.75, it might work out using your calculator, but you don't need the calculator. All you gotta do is know these 2 triangles. Like I said, you memorize these 2, trig life is simple. Okay? All right, the last one, some of you forgot that there was a number 51, was a word problem. Okay? And it said vertical height was fine, but it says a 12-foot ladder is resting against the wall. Okay? So here's my wall. The ladder's resting against it. So the ladder's, leaning against it. And it told me it was a 12-foot ladder, right? So I know how long that is. So I have a right triangle. Is resting against the wall, makes an angle of 52 degrees with the ground. Down here's the ground, right? This is my wall. That's my ladder. Down here's the ground. So that is 52. Yeah. Find the height to which the ladder will reach the wall. So they're asking for this. know, how high up on the wall does it touch? Okay, so I have this angle. What's this side? Opposite, hypotenuse, or adjacent? Opposite. What's that one? Hypotenuse. What's the one that has opposite and hypotenuse? Which of those three? Sine, cosine, or tangent? Sine, right? So that's what I write. Sine of 52 equals opposite x over hypotenuse 12. So all I have to do is multiply both sides by 12. Now, you gotta make sure your calculator's in what mode? Degree mode, right? So sometimes it'll get out of the right mode, so just check it. Mine's still in degree mode, okay? So I just go, why did I do that? 12 sine 52, close it up. So it's 9.45, so we'll just make it 9.5 feet. Okay, so you'll have a word problem similar to that on your practice quiz and quiz. All right, so Monday, we talked about complementary and supplementary angles and changing from degrees to radians and radians to degrees, right? Yesterday we did this trig stuff. Okay, that's all your quiz is going to be on, that type of stuff. All right, so I have a practice quiz for you to work on. We'll go over it tomorrow. Our quiz will be Friday. Any questions? Simple, right? Okay.